We can find the absolute maximum and absolute minimum, local maximum, local minimum for this function f of x on the interval. This is a closed interval -1, 4. The extreme value theorem says that for a continuous function on a closed interval, then f here's continuous function on a closed interval, f must have maximum and minimum on that interval. And this is how we find. You have the endpoints, so we need to compute the values of f at the two endpoints. F of -1, f of 4, and f of c, where c critical point. C is a critical point, and the critical point is a point where f prime of c equals 0, or f prime of c does not exist. Does not exist. So we will find all the critical points of this function on this interval, and we'll compare them, f of c with f of -1 and f of 4. And the biggest one will give us the absolute maximum. The smallest one will give us the absolute minimum. And we check each one of those, see the behavior of the function to see whether it is a local max or local mean. So let's do that and compute the derivative f prime of x. F prime of x is 3 times 4 x cubed, 16 times 3 x squared, 18 times 2 x. Now I know that here 3 and 4. 3, this one divisible by 4. This one I can also factor it in 2 and 3. So we have 3, 4 x cubed, 4, 4, 3 x squared, 2, 3, 3, 2 x. So 18, 9 times 2, 16, 4 times 4, and 3 times 4 I keep the same. Now we can group the common terms. Look at this, you see x and 12 in common. 12x, 2, 2, 3, so 12x in common. Now we can pull it out. 12x, inside you have x squared, 4x, 3. 12x, x minus 3, x minus 1. F prime of x equal to this one, and we want is equal to 0. So f prime always exists. So in this case, we look at the point C where f prime of c equals 0. So this one equals 0 gives us x equals 0, x minus 3, 0, so x equals 3, x minus 1 equals to 0, x equals to 1. So there are 3 possibilities here, 0, 1, 3. So we have 3 critical points. Critical points 0, 1, 3. So we need to compute f of c for 3 points, compare them with 1, -1 and f of -4. So let's do that. X here, let me draw f prime of x because we want to find the local max and mean. F of x. You have -1, 0, 1, 3, 4. -1, f of -1 at the end point. F of x is this. And f prime of x equal to this one, f prime of x. Here. So to make it nicer, I rearrange that 0, 1, and 3. Now f at 0, 0, f prime at 0, f prime at 1, f prime at 3. So these are 3 critical points. F is minus 1. So you have 3 minus, so 16 plus 18. You have 37. F prime at 1 is 37. F at 0, 0. F at 1, 3, 16, 18. So it's 5. F at 3, 3, 3, 4, 16, 3 cube, 18, 3 square. You have minus 27. And the last one, f at 4, 3, 4, 4, 16, 4 cube, 18, 4 square. This one you have 32. So now you can see the smallest one here, minus 27. This is our absolute mean. Absolute minimum is f of 3, which is minus 27. So we have the answer for the absolute mean, and the biggest one, 37. This is our absolute max. Absolute maximum. 37. F of minus 1. 37. So we have absolute mean and absolute max. Now about the local means and max. So here's to do it carefully. You see that on the interval minus 1 to 0. So this interval x is negative, x is less than 0. This term will be negative. This term x negative, so this term negative, negative. So x less than 0. X less than 0. This term f prime of x is negative. X less than 0. F prime of x negative. So I put the negative sign here. And f prime negative, this means derivative is negative, the function is decreasing. This is decreasing. And it's actually decreased from 37, decreased to 0. Yeah. Now I do similarly for this interval, 0 to 1. So x bigger than 0, the first term positive. X less than 1, second term negative. X less than 1, third term negative. Positive, negative, negative, make it positive. 0 less than x less than 1. Here I can put minus 1 there to fit the question. So 0 less than x less than 1, positive, negative here. Negative times negative. So f prime of x is positive. Positive, we have it here. Derivative is positive, function is increasing from 0 to 5. Now similarly you do for 1 to 3. for x bigger than 1, less than 3, positive, positive, negative. So this one is negative. F prime of x, negative there, negative. So the function is decreasing, and it is decreasing from 5 to minus 27 to the absolute mean. And then the last one, bigger than 3, positive, positive, positive. X bigger than 3, less than 4. F prime of x, positive. So it is increasing. It's increased from minus 27 to 32. So we see that you can see the behavior of the function. So it's go down, go up, go down, go up. That's how the function look like. So if I just sketch that, I see this graph should be like that, very high, 37, go down to 0, go up to 5, go down to minus 27, and go up to plus 32. So this is our absolute max. 37 is up here. Absolute mean minus 27 is here. And this point is 0. It gives us a local minimum. Local minimum here. Local mean. And this one, so 0 here is a local mean. Then we have another one here, local max. Local max here, 5. Local max. Local mean equal to 0, equal to f of 0. Local max 5, which is f of 1. And this absolute mean will also be a local mean. So let us write down the conclusion. Local maximum f of 1 equal to 5. F of 1 equal to 5 at x equal to 1. So the values local max equal to 5 at x equal to 1. We have two local mean, and one of them will be the absolute mean. Local mean 0 equal to f of 0, and local mean minus 27. F of 0 equal to 0 at x equal to 0. F of 3 minus 27, so at x equal to 3. These are two local mean. Absolute max, absolute maximum. It is at f of minus 1, so 37. F of minus 1, 37. At x equal to minus 1, one of the endpoints. Absolute mean. F of 3 minus 27 at x equal to 3. So this is a conclusion.